The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. Apologies for the late start again this morning. Once again, we're having difficulties with the old Barnsley internet, but hopefully you can all hear me and see my screen, which I've just got a little simple mill turn part on. My name's Les Boland. I'm one of the technical engineers here at SolidCAM UK. And today's webinar is going to be on the more advanced style of mill turn machines that are now currently becoming very popular and ever more complex as it happens as they get developed. Now then, I don't know whether you chaps have already got mill turn machines or considering buying mill turn machines, and are perhaps a bit daunted by the complexity of the things. You know, the fact that they need several programs, at least 2 programs running side by side to run various programs, one on the front spindle, one on the back spindle perhaps, and you're using 2 turrets at the same time and so on and so forth. These machines are getting, as I say, ever more and more complex, and SolidCAM is constantly being developed to take this into account. So I'm going to show you today that there's no need to be sort of daunted or put off by the complexity of these machines and how difficult they may or may not be to program. It really is no more different to program a mill turn lathe, or no more complex really to program a mill turn lathe with several spindles and several turrets than it is with just an ordinary mill turn lathe with a single turret. It's going to take you longer, that's all, because it's obviously more complicated and there's more operations and there's more things to consider. Okay, I don't know either whether some of you chaps were at the first of the series of webinars where I sort of introduced mill turn and how it all works, but in essence what you have with a more complex type of mill turn lathe is a series of sub-machines on that machine, or relationships between components on that machine. So you've got your front spindle and your back spindle, you've got your upper turret and your lower turret. So each of them has a relationship. So you've got a sub-machine of an upper turret and your front spindle, your upper turret and your back spindle, and again with your lower turret and your different spindle. So you've got 4 actual sub-machines within that one machine. So it's no wonder they get more and more complicated to control. But in SolidCAM we can do that. We can control these relationships between various machines. So the first thing I'm going to ask is what do people think about when they think about a mill turn machine? What image does that conjure up? Because they're now ever more changing as time goes by. I mean, you can have a traditional style of lathe with the front spindle where you'd expect it to be on the headstock, and the back spindle on the right hand side where the tailstock would normally reside on a conventional lathe, and then you would have an upper turret where you would expect it to be, but often you have a lower turret as well. That's the conventional idea of what a mill turn lathe is, but I have they're getting ever more complex. This machine you see on here on your screen now, would you consider that to be a mill turn lathe? Well, it's not a lathe, evidently. It's a 5-axis machining center with a cradle, an A-axis cradle here, and a C-axis that rotates about the Z-axis. So, is this a mill turn lathe? Well, let's just have a look at it, shall we? There we have the conventional milling side of things working away. But I'll just turn that sound down a tad. It's a bit noisy. So there we have a conventional milling operation going on this this lathe. But if I just zip it on a bit, you all of a sudden we're in a milling out the inside of this pocket here. But you'll soon see that this milling machine, as we can see it's static. There's the 4th and 5th axis are static at the moment. They aren't doing anything. We're just conventionally milling, but but we're doing an angle now on there. Hello, hello. This is now this has become a mill turn lathe all of a sudden. We're milling still, but it's turning. So this is a milling machine, as you can see, in the conventional sense of things, or a 5-axis machining center. But all of a sudden, it's taken on a whole new sort of identity, if you like. Now I'm just going to whiz it on a little bit further. Hopefully I can get things in the right place. Bear with me a second while I try and whiz this thing on. Hang on a second. Yeah, we're still doing milling conventionally. Bear with me, it's a while since I've looked at this video. It's dancing about all over the place doing the milling job. There is a turning operation somewhere on this. Where are we? I think I might have missed it out. I think I've skipped it. I should have looked at this more closely as I was. I'll give this a few more seconds to find it. Otherwise, I'm going to give it up as a bad job. It's been turned there by the looks of it. Yeah, I think it's going to get turned after this operation here. Bear with me. You'll see it. All of a sudden, this what everyone would consider to be a normal 5-axis machining center becomes a lathe. Yeah, that's. Oh well, I do apologise. There is a part on this video. I didn't want to go through the whole video and just bore you to death with watching a video, but this does get turned at some point in a conventional manner. Perhaps this is this next operation coming up. If it's not, then I'm going to bin it and move on to the next object of the exercise. Here we go. Say hello. We've got a mill turn lathe now. It's 5-axis machining center is now a lathe. So as you can see, this is one point I was trying to make. The convention of what is and what isn't a mill turn center is changing all the time. So this is where we would use our mill turn software on this type of machine. You'd use your 5-axis machine. You'd use your 5-axis strategies, and you'd also use your mill turn strategies together on this one complicated little machine. And this is just a one tool and one spindle that we're talking about here. So the conventions are changing, as you know. So this particular job here that you see here could easily be done on that machine that we've just seen in the video, or it could obviously be done on the conventional idea of what a mill turn is. So how do we go about that? Well, what I've already done on this part is I've created some toolpath for the turning operations. So far, so straightforward. I've just faced it off there. I've turned it there, and I've just done that little recess, and I can run through that with you briefly. This is conventional, and once again, this is for more advanced machining on this module. So what we've got here is we've got a sub machine here. This is the way this machine has been set up because it's got a front spindle, a back spindle, and 2 turrets. So we have 4 sub machines. We've got an upper turret with the main spindle, lower turret with the main spindle, upper turret with the back spindle, and a lower turret with the back spindle. They're the sub machines within this machine, the relationships between each one. And of course, each sub machine needs its own coordinates. Now, upper turret main spindle is my master coordinate 1. Upper turret main spindle, I've titled it that, just so that you've got some idea as to what it is that you're choosing, because it can get complicated if you don't have a naming strategy. So we're going to turn this facing operation on here, and the same with the second operation. I'm going to turn that outside, and it's using the same upper turret main spindle. It's actually using the same tool, as you can see in the tree there. And then the next operation is going to be a excuse me a second. is going to be another turning operation using the same coordinate on the upper turret, but using a different tool. You're using tool 2 on this occasion. So I'll just quickly simulate that. And here we are with our tool, and I'll just let that run. So we're facing it off, turning it down to a straight diameter, and then I'm just cutting that little piece out in the center there. So you can see that we've machined that part there. Now what we've got to do, as you can see, we've got some milling to do on this right hand side, and we've got some holes in the center part there to drill or whatever we want to do with that. So in the world of machining centers, if we imagine that we are using a conventional style of machining center on this part, and we're going to have it in the left hand spindle, the main spindle, and we're going to be using the upper turret to which is also our milling turret. The lower turret hasn't got milling capability on this particular machine. I don't think it has, but we'll use the upper turret to do the milling as well. Now there's two ways of doing this. You could have if we were to think about this hexagon on the right hand end here, you could have the milling cutter laid horizontally in line with the Z-axis and mill it that way, or you could have it vertically in line with the X-axis and mill it in that convention as well. So it's all down to preference, I suppose. I don't know which one of you people would what you would choose. I'm not sure either gives a particular advantage. I dare say that the horizontal one gives you more. If you had more clearance, if it was a larger part, you could have more clearance with the cutter laid horizontally than you perhaps would with a cutter sticking out vertically. That's about the only difference I would suggest. But horses for courses, people who choose things for different reasons. What I'm going to do is I'm going to do it horizontally and then show you how you would use it vertically. So without further ado, we'll add some operations on here. So what I'm going to do, this is the way I like to do things. You'll notice, by the way, that our coordinate is set obviously in line with the machine. Our x-axis is pointing up towards the X, and it's put towards this flat rather. And this is how I like to do things. If you've got a feature that you know you're going to machine at some point, I like to align my X-axis with that feature. So I've aligned my X-axis with this flat on here, and the reason I chose that particular flat to align my X-axis with is because we've also got a hole that's in line with that. Lucky me, because if you look at the other holes, they don't line up with any flat, but that one does. So my thinking was that I bet they are timed on this part. I don't know, but if they are timed together, then obviously to have them in the same coordinate would make sense, and you can tie them together perfectly. I mean, they would do it anyway, but I just like a bit OCD with things like that. So the way I'm going to machine this is at the moment I'm going to have the tool laid horizontally, and I'm going to rough it out one flank at a time. Then I'm going to finish it by going around the whole 6 sides together. So the way I do that is I'm going to add a milling operation, and I'm going to add a profiling operation, and my master coordinate position I'm using is the upper turret position, and my submachine obviously is the upper turret main spindle. So I'm going to create a geometry line on here exactly as you would in normal milling. I'll choose that line there and accept that line. That's the direction I want to cut it in. Yes, I know it's not climb milling, it's conventional milling. I'm going to go in that direction, but I don't know why. I just like it on mill turns going that way. Okay. So there we are. We've got our contour. Next thing we need is our tool. And remember, this tool, this I'm going to be selecting, is laid down in the turret as being horizontal. Have I picked the correct one there? Yeah, it's displaying as being vertical. Yeah, select that. Let me just check things. So, yeah, it is laid down as horizontal. Once I've selected it, it picks up your geometry. Sorry, your coordinate that you're working within, and it lays it down there for you. And you can see that it's there. Actually, the little picture in the corner is not necessarily the orientation of the tool. Sometimes it does show in the picture in a different orientation. But once you put it on your screen, that is the orientation that your tool will appear in. Okay, levels next then. So my upper level, remember we laid down, so my upper level is here on my end face, and my profile depth, remember to get used to taking the information off the model. See the box turns pink there. This is the same for any operation that we do. Take the information directly off the model, then if the model changes, your toolpath gets updated automatically, should you want it to do so. Okay, so there's our levels. Our technology down here, once again, same as any normal conventional milling operation. I'm going to rough it out and not finish it. I'll finish it in a second operation, so I'm roughing it out, step down to 5mm. I'll untick the finish operation because I don't want to finish it at this stage with this tool. And I'm going to step down 2 steps at 5mm. I'm also going to clear offset and step over into the profile. So I'm going to step over 5mm and step back in 5mm. So it'll do 2 cuts off the face and then 2 cuts down. So that's the way that works. I'm going to change my tool side to the right side because I'm going to be conventional milling. I'll just check the geometry there, and you can see there where my tool is going to start and finish. And if I just show you that end on, you'll see that I'm going to start and finish within the boundary of the turned diameter. So what I would like to do is extend that little value out a bit more than that, perhaps 8mm, a little bit more than that. It's going to be 10mm, isn't it? So if I make that 10mm, my first cut is going to approach off the diameter that's already been turned, so we're not going to go whacking into it. And I'm going to extend the end by the same amount just for neatness. So there we're going to completely mill a straight line right across that part to give it a hexagonal cut. Well, it's going to be part of a hexagonal cut when it's done. So I'm happy with that. That's what I want to do. Give that the green tick. And in link, which you would normally put your lead in and lead out, well, I don't need to do that now because I've just created it for myself in the geometry. Very handy that is to do that. So what I've got a wall offset of 0.5 for my finished cut that I'm going to do in a minute. So I'm going to rough it out, leaving that 0.5mm on. And my wall, obviously in this case, is that feature there, that flank. So that's my wall in this case because that's where I'm laid down with my tool. Okay, so I'm going to save and calculate that, and wait for it to have a bit of a think. Okay, it's a bit slow, my laptop, with being plugged into the old Barnsley net. Okay, we can now simulate that on our part, and here we are with our pre-turned part, and you can see the stock there in blue that's still around that hexagon. So if I'll just single step this, in we go, first cut, across, up. I've not told it to stay down. I've told it to retract each time it comes back. So there's our first level, and here's our next level of cut, and there we are. That's that done. That's that. I'll just quickly play that for you again. There you go. That's that operation done. Obviously, that's only one of my hexagon flanks that I've done. So what I need to do now, easiest thing to do, is to transform it. And now I don't know whether any of you are using SolidCAM at the moment or SolidCAM 2014, but in SolidCAM 2014 we can now transform it from within the same window that the operation is in. So we click on the transform window and we get our operation there that we've just created. And what I can do is wrap this around the fourth axis now, which is our spindle. Click on fourth axis, include the original operation, and I want to add 5 more operations to that, and I want them to be 60 degrees apart, which is obviously for the hexagon. I'll insert them operations now, and here we go. We've got our transformations around the fourth axis. First one is the operation you've just seen, and it translates it around the axis to get to the last operation at 300 degrees. So OK, thank you very much, and OK that, and I shall just save and calculate that again. And now we'll simulate it again, and you will hopefully see it go around each of them flanks all the way around that part. So this is our hexagon being roughed out. I'm just going to have a sip of tea at the moment. I've been talking too long. Excuse me. Okay, so there's our hexagon roughed out. Now I'm going to finish it in a slightly different fashion, because I'm going to finish it all the way around. So come out of this. I'll name that actually. You can get used to naming these operations. So I'm going to call this the rough hex horiz. There you go. Rough hex horiz. Save that. Close that down, and we call it rough hex horiz there. And you'll see that will that naming convention, it will appear in your posted out G code when you come to G code it in your list, so the guy knows exactly what it is he's doing. Okay, we'll add another milling operation now, and once again it's going to be profile, and I'm going to start. Sorry, yeah, same convention. Geometry is going to be in the Mach 1 upper turret position, upper turret main spindle, and I'm going to create a new geometry line, starting off at the same position, but this time I'm going to go all the way around. So I'm going to go into auto constant Z, and you'll see that it's automatically in line with the Z axis plane, created a loop there around. So yes, I do want to accept that, thank you very much. And now I'm going to choose my tool again, and this tool is going to be my next tool, smaller tool, different tool. Select, and the reason I've chosen a different tool really on this operation is because it's a different colour, and you'll see that when we simulate it, you'll see it'll be different colours, so you know what's done the finishing and what's done the roughing. Okay. Levels, once again, it's got the information there, it's correct, but let's take it directly off the model so that we know that if the model changes, we will be updated and I don't have to do the whole thing again. That's the way that works. Okay, technology this time. Now our geometry, it's once again, it's going to be on the right side. If I click on geometry here without changing my tool, you'll see that my tool is there on the inside. So it's a quite obvious little reminder to just check that. Even if you don't want to change your geometry, which I don't, it's a good thing to get used to having a quick check just to make sure that you are doing what you think you're doing. So I'll change that to the right hand side and just check that my tool is come off there. Yeah, and there it is. It's on the right hand side of the line now. Okay. And I'm just going to do a finish cut, one finish cut, all the way around that profile. So I can lead on, I can do a lead in, I can arc in and arc out of that finish. And now I can save and calculate that. And I'll simulate that. We haven't got any stock for some reason, but you can see that goes all the way around there. Let me just run the two milling simulations together. There we go, we've got our stock back on. So we're going to see our roughing milling operation that we did with using the transform function, and we're going to see the finish one where it goes around in a conventional manner where it just cuts a profile. So once again, here's our roughing. Apologies if it's a bit boring because you've seen it before, but it's easy to see the whole shebang together there. So there's our roughing and there's our finishing. Okay, job done. So that's one way of doing that milling operation. And as I said at the beginning, there's also the other way that you can machine that by machining it vertically. So what I shall do, I'm going to delete them two operations now that I've just created. So we're back to where we were, and I'm now going to create a operation where we can machine it in the vertical plane. Okay, so what we need to do first though, we need to create a coordinate in line with the x-axis that the machine can relate to. So we need to create a second position under that first Mach position with the Z pointing towards the outer diameter. So in our coordinate system manager, here we have our coordinate positions for each of the submachines. As you can see, I've named them with the with what they relate to, just so that you know what you're working to. So the first position is upper turret main spindle, second one is lower turret main spindle, etc., etc. You can see there. What I need to do on the upper turret main spindle, which is where my milling cutter is going to be, I need to create a second position under there. So if I click on the add button here, it's automatically given me the option to create a second position under the first Mach coordinate, which is very nice because that is exactly what I want to do. So there's several ways of creating your Mach position. The thing I want to do, the first thing it wants to do, as ever, is it wants you the face that you want to go on. Now I could click on this end face and then flip it over or whatever, but if I'm going to come off this face, I might as well click on that face. So there we go. I'm on that face, and it's put my little trident there on the top center of the model box, which is what I've got it set to there. I mean, it could stay there, it doesn't matter. All that we are interested in at this stage is that the Z is pointing in the direction that the cutter is pointing in. That is the whole point of it. It is the fact that the coordinate is right up there doesn't matter anything because it is related to the original one. So SolidCAM will make the necessary calculation and move the tool accordingly because it is that position is related to your original position. But what I like to do for tidiness, just because I have got OCD, as most engineers have, I think, I like tidiness. So although my Z is pointing in the correct direction, the fact that the X is pointing along the spindle is not necessarily important, but I like it to be that way because it's the same convention as it would be if it was in a vertical milling machine with a fourth axis, just like it for neatness. Also, bear in mind that the x-axis on this coordinate is in line with the machine's z-axis for future reference, because we will need to know that because for something I'm going to show you after this when we do the drilling. So my z-axis pointing up, x-axis in line with the spindle. Now I'm going to change where it is, because I'm going to pick origin. I'm going to plop it right there where the original one is, just because I can. Okay, green tick, and away we go. So now I've got a second position under my original coordinate for my rotational position for the milling cutter, and I'm going to call this coordinate mill vertical. I mean, if you were just in line with a flank, perhaps you might just say call it mill hexagon, mill or whatever. But we also know that it's in line with a hole, and we can use the same coordinate to drill that hole with, and that's why I aligned it the way I did. It's all about thinking ahead as to what you want to do with these machines. Think ahead as to what features you're going to want to machine in any of these coordinates, and obviously you want as least coordinate changes as you can, just for neatness, because it can get a bit complex and a bit untidy sometimes. Okay, so now that we've created our coordinate, by the way, I've created a setup at the head of our toolpath here, and if we have a look in there, you see what I've created in our setup. We've got our lower turret, main spindle, blah 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 here in line with our particular master coordinates for that, just to show you that there. Okay, you may see the model go far away on this when I'm doing this with these coordinates, because there's obviously someone's left something, a feature on this model that's out in space somewhere, so it disappears occasionally, so bear with me with that. Okay, so what I'm going to do now is we're going to mill this feature once again using the vertical machining method. So once again, add milling operation, same thing, profile. This time, coordinate system, I need to change that to my milling vertical position, and you'll notice I've got no geometry under there now. Even though I want to create the exact same geometry line in the same way as I did earlier, obviously that geometry line is only related to the master coordinate. So now that I've created this coordinate, I've got no geometry that is related to it, so it's got to be created again, even though it's the same line. It's the way SolidCAM works. The conventions are very strict on that, so that you don't get you aren't able to use the same line in different coordinates and confuse the whole shebang. So this is going to be created again. So new, and there's our geometry line. I'm going to do it in exactly the same way, so in the same direction as before. But you'll appreciate now that because the tool is vertical, now that we're going to go in that direction, we are going to be climb milling. So we're going to be left of the line this time. So there's our line that I created, same as I created earlier. Give it the green tick, and that's the line we want. Tool. This time I've got a different tool that is in the vertical position. It's 10 millimeters again, same as before. I'll select that. See, it shows you it horizontal there, but when you come to hover above your screen, you'll see it's in the vertical. So that's not always in the correct position. It's just what the default position is on the machine. Because of the type of machine that this is, it's only got one tool holder in the upper turret. It's got a tool changer, you see, and you've got to choose when you're setting your machine what your default position is. And in this case, it's horizontal, so that's why you get your tool set up like that. But it'll always on the screen show you it in relation to the current coordinate position. Okay. So in our levels, this time, our upper level, and this is where we get our information off our model. Now it's come up with that figure there because it thinks it's up here somewhere. Don't know why. But I'm going to click on the model geometry itself, the point there, and that's where we get the pink in relation to the part there. So that's the diameter of that, and if I just click on the face that I'm machining, comes up with the position of that face, and then it'll give you the depth of where that is, the cutting depth of that face. Okay. Technology, I'm going to do it exactly the same as before. Well, actually, I'm not actually. I'm going to rough it and finish it with this with this one tool this time, because time is running on, and I don't want to be doing the same thing as before. You get the idea. So I'm going to step down again, 5mm step downs, and I'm going to step across in exactly the same way, 5mm off, 5mm in. Okay. So there's our strategy. Rough 5mm step down, leaving 0.5mm on, and 5mm step over, and then I'm going to finish it all at the same time. Okay. One thing I haven't done is looked at my geometry, so I'll quickly do that now. In our geometry, and then you can see we're in the vertical plane, and once again you can see that our geometry needs to be extended the same manner as it was earlier. So now I know that needs to be 10mm to hold off. Oh, look at that. Oh, just, yeah, it's off. It's off by yeah, pretty much the same as it was before, and 10mm at the end again. So there we are with our extended geometry lines. Give that the green tick. You also notice there's a little pencil icon appears there. That's to show you that you have edited the geometry in one way or another. So that's just to show that. It's a nice little addition that's just been added in SP2, I think it was added in. Okay, and this is SP3 I'm running, by the way. So this is the latest version that was just released on Monday, I think it was. Monday this week or Friday last week, one of the two. So this is the up-to-date version. And so now I don't need a link or anything like that. So I'm going to save and calculate this, same as I did for the horizontal method. Okay, and we can simulate that now. So here we go, vertical. And there we're doing the step down the same way as before. But you notice because it's horizontal, it's done it. Oh yeah, and the finish. Because it's vertical, it's doing it down to the X level first. So we can change that by doing the complete Z level option. Save and calculate it again. Just take a stamp on my machine. I'll simulate that again, and we can now hopefully see that it does it in the same way as it did it horizontally. There we go, with the finish at the end as well. You may not want to finish the end like that, but this is the way I'm doing it for time's sakes. So that's that, and once again, exactly as before, we transform it around the fourth axis. 60 degrees, 5 extra steps, insert, OK, OK, save and calculate. Simulate. So there we are, exactly the same operation done in the vertical plane, which is obviously handy if you have a machine that doesn't have tools in the horizontal plane, for instance, or just that you like it that way. Okay, so there's the two different ways of creating that hexagon using your milling cutter. Everyone okay with that? I mean, if you have any questions as to what I've done there, please use the ask question function that's in the on your webinar panel there. I think there's an option to put your hand up or something like that. If you think of a question after the webinar has ended, then you can email me at les@solidcamuk.com, or you can phone the office and speak to me or one of the other technical engineers here who will gladly talk through it. Okay, For the final operation I'm going to do today, this little webinar's taken me a lot longer than I intended to get to this stage, but this is going to be my last operation on this webinar. I've yakkered on for far too long. So what I'm going to do is I'm going to drill on this diameter here. These however many holes are they? I don't know actually. 1, 2, 3, 4, 5, 6, 7 holes. Yeah, 7 holes on that diameter there. Okay. Several ways of doing this. I'm going to show you the easiest one. I'm going to add a drilling operation. So add milling, and it's going to be a drilling operation. And it's already remembered my Mac position from the previous one. It'll do that. So unless you need to change it, you're okay. So it's the correct one for me. I'm using the same coordinate because that the hole is in line with that flank there. If it isn't, I'm going to preempt one of your questions here. If it isn't in line with it, you need to create another coordinate for it. So if none of them holes lined up with any of them flats, I would have to create another coordinate for that, for a hole. So just bear that in mind when you're trying to plan your job ahead of time. But yeah, these are timed together, so they're lovely. Okay, right. So what I'm going to do first, before I select my geometry, I'm going to tell it. And if you see this little arrow here, it's almost like it's been designed here. This arrow to be hidden. You know, as if you could. I'm just going to put this little blue arrow here for no reason at all. But if you drop that down, you'll see that you can select whether you're using it in the plane mode or around the 4th axis. So I'm going to obviously be using this around the 4th axis. So if I click on around the 4th axis, then click on my geometry, and then choose, and remember this, remember I said around the x-axis, because it's not around the z, it's around the z-axis of the machine, but it's around the x-axis of this coordinate. You've got the options there to change it, but x is correct for this. So our x-axis is in line with this spindle, remember. So we're going to rotate our geometry around that axis. So I'm going to look for full holes only. I'm going to pick the face. So if I pick that diameter now, it's found all of them holes and the positions, and it shows you a nice little graphic on the screen there that it's got center lines around through all of them 7 holes. So it's already done that for you. You don't have to pick it, you don't have to do a transform, you don't have to do anything. So there we go. Tick that and accept that. I'll pick my tool now, and I don't know what size them holes are, I've never measured them, but I've got a drill in here, and it's a 6mm drill, and I'm going to bang some 6mm holes through there regardless of what the drawing says. So I'll select that, and there we have a drill in the right plane, and hey ho, I tell you what, that's not far away, that is it. Okay, this time once again levels. The levels obviously we like to take directly from the model. So my upper level is this diameter point here, and my drill depth, if I have a look down there, click on the bottom of that hole, that's the bottom of it there, you can see it inside. So there's our drill depth, and I'm just going to cut a tip. I'm aware that this is a flat bottomed hole, and I'm aware that my drill has a point on it. I'm just going to ignore that small fact for the object of this exercise. Obviously in the real world I would make sure I've machined it correctly. Okay, the technology I'm going to use is straightforward drilling. It matters not what I'm using. I'm just the object of the exercise is to show you how to create this operation. So I'm just going to use conventional drilling and save and calculate that, and we'll see what it does. What I'm guessing it's going to do is not do it in the order that I want it to do it in. because there's the way the model's been created, etc., has a bearing on how it's going to machine it by default, and that's what I'm using. I'm using the, if you look here, default method. So let's see what it does do. We're going to simulate that again. It started over there. Why it started over there, Lord only knows. It'll be something to do with how the model was created, and that's the way that is. So it's done that one, and hey oh, it's gone over there. It's gone over there, and it's gone over there. So it's making its own damn mind up in which order it does this drilling operation, which to any man is completely illogical and crazy. I'll just play that again so you can see it's just it misses every one out, then comes back and fills in the gaps, if you like. So what we can do is we can change that. You can try and do shortest distance. I'll save and calculate that. I'll show the sorted. Come on. I'll show the sorted toolpath. Let's see what it picks up with. Actually, you can't tell from that. Let's just put our toolpath on and see what it's actually doing. And you see by the red dot, that's the way it starts. So it's starting there, going round there by the looks of it, and then going all the way round this way. So it's still not what we want. I'll simulate that quickly just so you can see what it's doing. It's starting there, then it's going down there, it's going over there, it's going over there. So it does it sort of, not quite correctly. So what we've got to do is we've got to go in the advanced. And there isn't a pattern for what we want to do, but what I'm interested in doing is picking my start position. So if I start it, let's see if this works, start it there, okay, just having a think again, and let's have a look at what it's done. Yeah, you can see now it's starting at that position and it's moving all the way around as you would want it to. So there's a little trick for you there. If your tool isn't going or doing what you'd expect it to do or what you'd like it to do, there's a little way of setting it to do what you want. There you go. Okay, that's the drilling operation, and it was quite easy, apart from the fact that you had to tidy up the order that did it. Selecting the holes using that method where you choose that it's wrapped around the 4th axis, you pick your face, it finds the holes, bingo, job done. Couldn't be easier. Okay, that's been 50 minutes that I've been waffling on now about mill turn. As you can see, no difficulty, very easy, no complexity. I know that I've just done this on a single turret with a single spindle with a single turret, but it's exactly the same convention when you are working on other turrets and other spindles. You've just got to make sure that you've set your machine up correctly, you've got your coordinates set in the order where you want them to be. If you think about it, it makes sense, it's logical. If you look at the coordinates here, we've got the let's just have a look. I'll zoom in there. Our first one, upper turret main spindle, that's this one. That's the one that points upwards. Our x-axis is in line with the upper turret. The Z is pointing out. Our lower turret main spindle is this one here, where the x-axis is pointing down towards the lower turret, but obviously the Z is still pointing in the in line with the spindle of the machine. Let's have a look at the other end. We've now got another 2 coordinates here, and you'll see straight away that the Z axis is pointing in line in the same direction as the front one, because at the end of the day, that is the Z positive of the machine. This is what we need to do. Your coordinates have got to be in line with the axes of the machine. So Once again, same convention applies. Upper turret back spindle is the area the x-axis is pointing towards the upper turret again, and the lower turret back spindle one is where the x-axis is pointing towards the lower turret. Okay, and as we've previously seen, we've also got a one called mill vertical that we created, and that's this one here where you can see the blue Z arrow. I wish it wouldn't shrink when I zoom in. The blue Z arrow pointing directly up in line with the x-axis and in line with these two features here, the flank and the hole. Okay, and that is the convention. Once you get used to that discipline, is what I'm going to call it. It is because it is a discipline. It is the way you set your machine up, because the axes are lined up exactly as you would see them on the machine. Okay, has anybody got any questions on anything that they have seen so far? I shall wait for a few minutes to see if anyone has held their hand up. I must say right here and now that when I've done this in the past, I've not seen anything pop up on my screen, only to find out that about 4 people have held their hands up and I couldn't see it. So if you do have a question and I don't answer it, it's because I can't see it. So in that case, could you please email me at, as I'll give you it again, les@solidcamuk.com, or you can phone the main number of the switchboard and they'll put you through to me and we can have a little chat about it. But I hope from this webinar you've gained some confidence in how we can control every aspect of the ever-increasing complexity of mill turn type machines, whether you've got one spindle and one turret or multiple turrets, multiple spindles, B-axes on your turret and all sorts. It can all be handled with SolidCAM mill turn. Okay, nobody's asked any questions, so I shall end this webinar forthwith. Thank you very much for attending. Have a good weekend, everybody, and I'll hopefully see you in the next webinar. Goodbye. Thank you very much.